Good evening. Welcome to Exponential Expressions. Well, kids, we're about to start talking about powers. You may know a little bit about it, but we certainly haven't touched on it yet this year. So first we've addressed what is an exponential expression. Well, it's an expression, a math problem, that doesn't have an equal, meaning it's not an equation, but rather an expression. That's what makes it different, no equal sign. The power, or the exponent, tells you how many times the base, and in our problem the base is 5. So when we write 5 and we raise a little number over here, we could read that 5 to the third power, or we could call it 5 cubed, or we could say 5 to the power of 3. All of those are accurate. There's a lot of instances where powers are used. Algebra is one of them, but there's others, and we're going to talk about when exponents are appropriate to use. It's important to know the difference between the base and the exponent. So the exponent is telling us how many times the base is being multiplied by itself. So if we scroll down a little bit here, 5 cubed, or 5 to the third power, just kind of erase this right here. You think it wouldn't do that when you're using the mouse, but it does. So 5 times 5 times 5 is another way for us to write this expression. This would be numerical, whereas 5 to the third power is what we call exponential. If you don't use an exponent, then you can't call it an exponential expression. As we've already said, 5 is the base, 3 is the exponent, or the power. Well, you might be thinking, well, when are we ever going to use exponents? Well, there's actually a lot of times, especially to represent either extremely large numbers. Some large numbers can be expressed utilizing exponents, or very, very small numbers. 100,000 is a power of 10. Because it's a 1 with just a string of zeros with it. It can be rewritten as 10 times itself 5 times, which is 10 to the 5th power. If we had 10, say we had the number 100, that would be 10 to the 2nd power. 1,000 would be 10 to the 3rd power. The number of zeros tells you the exponent. So likewise, if you have a really tiny number, this is 1/10, tenths place, not 1/10, sorry, hundredths, thousandths, 10,000ths, and then 100,000ths place. So in fraction form, we have 1/100,000. So if we replace the 100,000 with 10 to the 5th, this could be expressed as 1 divided by 10 to the 5th. I went ahead and wrote it using a negative exponent down here, but we're not actually going to be tackling negative exponents in the 6th grade, but you will in pre-algebra. And basically negative exponents, if you take the reciprocal of this, you can express it using a negative exponent. So if you involve yourself in some of the enrichment activities for Unit 2, you will get a chance to work with some negative exponents. All right, well, let's go to the next page. You might notice that I mislabeled my points here. This is actually the 3rd one, which would just be C, but it's really not that big a deal, so don't let it bother you. Another good use of exponents is when you're writing the units of measurement for area and also volume. Area is a measure of flat space. So if you multiply 1 meter by 1 meter, when you express the area, it's actually square meters. And a square meter is really just a meter, a square, that's a meter on every side. So a square mile would be 1 mile by 1 mile by 1 mile by 1 mile, like a giant square. So area is measured in square meters, square miles, square feet, anything like that. Volume measures capacity, or in other words, how much is something going to hold. So when you talk about how much something's going to hold, then you're talking about three-dimensional space. How much will this box hold? Well, if you took a box that was 1 meter by 1 meter by 1 meter, a cube, in other words, the volume would be the length times the width times the height. And in this case, if, for example, if they were all 2, then the volume would be 8. 2 times 2 times 2, or 2 to the third power. A meter times another meter would be meters cubed. And we can either read that as meters cubed, or we could call it more appropriately cubic meter. A cubic meter just means you have a cube that's a meter on each edge. Then one last way to use exponents is to represent different units of metric measure. The metric system is based on powers of 10. Kilo means 1,000, and as we talked about earlier, 1,000 is 10 to the third power. So I could either say I have 1,000 grams or I have 10 to the third grams. Rewriting numbers in exponential form can make some other calculations a little bit easier down the road. So if you weren't ever sure and you kept hearing the term megabyte and gigabyte, then you might be interested to know that mega means million, so 10 to the 6th, and giga means billion, 10 to the 9th. So 1 gigabyte really means a billion bytes. So let's take a look at some practice problems here. Just asks us to write all these different numerical expressions, or some of them are numerical, and write them using exponents. So if we have 8 times itself 4 times, our base is 8 and our power is 4. If you have 10 times itself, looks like 7 times over there, so the base is 10, the power is how many times it's multiplied by itself. It's important to note that 10 to the 7th is not equivalent to 70. You never multiply the base times your exponent. This would be a 1 with 7 zeros. That would be 10 million. Very far from 70. Well, if you take that idea of a base and the exponent and you just apply it to something else, like letters in this case, a times a times a, well, the base is a because it's what is repeatedly being multiplied, and you're raising it to the third power. So likewise, a meter times a meter would be a meter squared, or you could write the word meter. M is just the abbreviation. Likewise, the abbreviation for a centimeter is cm, so centimeters cubed, or you could call that a cubic centimeter. So it wouldn't matter if we had the word friend times friend times friend, it'd be friend cubed if you apply this meaning of an exponent. Not quite sure what my pencil's doing there. There we go. So let's take another one, 2 to the 4th. So now we're going in reverse. This one is asking us to write, I'm sorry, as usual, having a little bit of technical difficulties here. So let me try to get my pen working a little bit better. Okay. Actually, I think I want to go to the highlighter so we can get that done. Oh, that's over here. Sorry, sound like a crazy lady talking. Right here it says rewrite each in expanded form first. It wants us to actually evaluate, and evaluate we shall once Miss Shaw gets her pen working. We will, but now it's got this doggone eraser here. I'm so sorry. We'll just move on with it. 2 to the 4th power is 2 times itself 4 times. So 2 times 2 times 2. That silly little eraser is just driving me crazy. 2 times 2 times 2. would be, I've just got to fix this. Let me pause for a moment. Okay, I got my pencil back instead of the eraser there. So expanded form is right here. When you write it all out kind of the long way, you're expanding what it looks like. This would be exponential form. This is expanded form. And when you evaluate, you're trying to get a single number to represent this whole thing. Well, 2 times 2 would give us 4. If we multiply these 2's together, we get 4. And now we have 4 times 4, which is 16. Now we've already talked about 10 to the 4th. We said that powers of 10, it was 1 with that number of zeros, but if we wrote it out in expanded form, it would be 10. I'll just use a multiplication dot this time, just to kind of emphasize the fact that you can use that if you don't particularly care for the parentheses. Sorry, it looks like I wrote it with my feet. 10 times 10 would be 100. And then the second 2 tens multiplied together would also equal 100. And then 100 times 100, the shortcut there is multiply the ones and then just tack on the number of zeros you see, which is 4. So you would get, even though that looks like a 6, let's fix that. I'm just kind of a train wreck on this one, aren't I? 10,000. There we go. And we box our answer. Now, probably the most challenging ones on this page are these last two. And while they may not affect you quite as much right now, they certainly will in the realm of algebra, which you'll be moving into next year. The difference in these two is big. Notice I've written underneath it. Let's highlight that actually, because that's important. Right here it says this one is not even read the same way. This one is read -2 to the 4th power. However, as much as students would like to read this one this way, that would be absolutely incorrect. Because this one, the reason I know that the -2 is not part of what's being raised to the 4th power is because the negative is not in parentheses. So the 2, which is right next to the 4, it is what is being raised to the 4th power. This negative is just sort of thrown out in front. So this one means raise 2 to the 4th and then take the opposite of it. So you get -16. Whereas over here, it means -2 times itself 4 times, which you get a very different answer. You get +16 because, as we know, a negative times a negative is a positive, so 4. -2 times -2 is another positive 4, and when you multiply two positives, you get a positive. So a lot of times a student intends to write -2 in parentheses to the 4th power, but instead writes this. And then in the rest of their work, they're actually inaccurate. So how you notate things in mathematics is really important. It's like using the word that you want to use when you're writing something in English. If you use a different word, you give a different meaning. Here, if you want to give this meaning, this is the notation that you use. And just because you know what it means, it doesn't make it okay, because everyone needs to know what you mean. When you change math language, you're changing the meaning. Okay, let me get back to my pen if I can. And let's talk about how to use exponents to write an expression, a numerical expression, using 1 power only. So we're not writing 4 times 8 as 32. Even though I guess technically that would be 32 to the 1st power. But we're trying to get some number smaller than 4 and 8, or as big as they are, and rewrite each number, and then get one expression that has a power in it. So 4 is equal to 2 to the second power. And if you multiply 4 times one more 2, you get 8. So 8 would be 2 to the third. So here it is in exponential form. If I rewrite all of that in expanded form, if I count them up, I see, oh, I have 5 2's. So it's 2 to the 5th power. Not 5 2's being added, but 5 2's being multiplied. So it's 2 to the 5th. A shortcut way to getting there, and I wrote right here, I can go from this step all the way down to 2 to the 5th if I just add 2 to 3 instead of writing them all out. It's fine if you want to do that. If you're confused at all, you want to write it out. So on this one, I don't think it takes a lot of thinking to realize, okay, we're going to need to rewrite 25 as a power of 5. Well, if you know your multiplication facts, you know 5 squared is 25. So if you have 2 5's and you multiply it times one more 5, well, you've got 3 5's altogether. So you could either write it as 5 times 5 times 5. That would be expanded form, but we're shooting for one power only. So we would have 5 to the third. So again, if you want to bypass the expanded form step, you certainly can. Let's apply these same skills to these 3 problems below. I suggest you pause the video and try these 3 on your own. Actually, we should talk about this little caution for just a second. A really common mistake is for a student to see this 2 and 3 and see that multiplication, and they want to multiply 2 times 3, which would not give you 5, which would give you 6. It's just sometimes hard for the brain to see that multiplication symbol and actually add the exponents together. So if you think that's going to happen to you, just write it out in expanded form and then just count, and you'll come up with 5, not 6. So try these 3 and then come back. Okay, well, I decided to multiply a little bit of this one out. If you decide to rewrite 16 using 4 squared, that's the easiest way to go about it. Keep the 4 to the third. I could write it all out in expanded form. So the pink is 4 squared, the blue is 4, and the yellow is 4 cubed. Then I can see that I have 1, 2, 3, 4, 5, 6. Or I could just add my powers. I have 2 4's plus 1 4 plus 3 more 4's. So the exponent right here would be 6. So 4 to the 6th power. If it wanted us to evaluate or simplify, we would actually multiply 4 by itself 6 times, which would not be a very pleasant task. But fortunately, we don't need to do that. Okay, let me erase this part right here so I have room to do the next problem. All right, so I think it's pretty obvious here we need to use a base of 2. So the 8 is the only one that really needs to be rewritten. So maybe right here, this 2 to the second, I'll just go ahead and write as 2 to the second power. Remember from before, we had 8, and we said it was 2 to the third. And I'll just bring down the 2 to the third that's already here. So if we have 2 2's and then 3 2's, that's 5 2's, plus 3 more 2's would be 8 2's. So it'd be 2 to the 8th power. And no, I don't know why half my equal sign is now black. It's magic. Now if you have 1b times another b, that's b squared. And then if you multiply that times another b cubed, now you've got 2 b's and then 3 b's, so that gives you b to the 5th. Or if you wanted to write it all out the long way in expanded form, you could do that as well, and then just count to see that you have 5 b's. Now there's 3 more problems, and the directions here ask you to give your answer in simplified exponential form. That is what we did up here. These are simplified exponential form. So we're still trying to get one exponent. So pause the video, try those. You could either check on the key or you could come back to the video. All right, well, let's see how you did. For this first one over here, if I just count, I've got 3 2's and then 4 2's, so I have 7 2's being multiplied together. 1 6 and 3 6's gives me 4, so 6 to the 4th. And 1 5 times 2 more times 3 more. So these last 2, that's 5, times another one gives me 6. 5 to the 6th power. Remember, 5 to the 6th power is not equal to 30. It is equal to 5 times itself 6 times. Much bigger than 30. Well, that wraps up exponents. You don't have a homework assignment over these properties of exponents, but you'll be using them later in some problems that we're doing with order of operations. Have a good time.